Review for Geometry Topic 1 test. Okay, at the beginning of this review, I have listed several different definitions. Make sure you know all these definitions for the exam because there are a few questions on the exam about these definitions. On this slide, I have the three undefined terms that we went over at the beginning of the year: point, line, and plane. Review those. There's also these defined terms, which are a line segment and array. Make sure to also review what collinear and coplanar are. And then on this slide we have the reflection and rotation rules. Now I'm going to give you the rules for the exam, but I would look at these ahead of time and make sure that you understand them really well because there's many questions on the exam where you need to use them or where you're asked about them. Remember that clockwise means in the direction of the clock, which is to the right, and counterclockwise is the opposite direction of the clock, which would be to the left. Make sure you're familiar with what parallel lines are and what perpendicular lines are. Lines that are coplanar and are equidistant at all points are parallel. That word equidistant, that means equally at an equal distance at all points. That word is on the test, so be familiar with it before the exam because it's on the test. And I believe this is the last definition. This is something that we didn't talk about a lot in class, but it's something that you need to know. A linear pair is when you have two angles that are adjacent. Adjacent means next to each other. So if they're next to each other, they share a common side. So a linear pair is two angles that are adjacent and supplementary. That means they add up to 180. An easier way to think about them is that a linear pair is two angles that are next to each other that form a straight line. All right, so if you look at the diagram on the screen, a linear pair is two angles next to each other that together they form a straight line, and a straight line is always 180 degrees. Okay, and last, remember that I said that all the transformations that we learned are rigid motions except for a dilation. A dilation is when you make a shape bigger or smaller. A dilation is not rigid motion. But a translation, a reflection, and a rotation, those are all rigid motions. That means that when you do those transformations, the shape will remain the same size. If it's rigid motion, when you do these transformations, the shape stays the same size. Alright, so now that we've looked at that, let's look at some of the questions that are similar to what's going to be on the exam. Here's our first question. It says select each transformation that carries a square onto itself. That means select each transformation that will make the square look exactly the way it looks right now. So in letter A, we have a rotation of 180 degrees clockwise about one of the square's vertices. All right. The vertices are the four corners of the square. So let's pick one. Let's say we pick that vertex of the square and we do a rotation 180 degrees clockwise around that point. If we do that, this would be a 90-degree rotation, and if we do that again, this would be 180 degrees. As you could see, that does not put the square on top of itself. So therefore, that answer is wrong. Let's look at letter B. Letter B says a rotation of 90 degrees clockwise about the square's center. By the way, when you see the word about, that means the same thing as around. You could think about it as around the square's center. Okay, so there's the center of the square. If I rotate this square 90 degrees clockwise around its center, it ends up looking exactly the same. So therefore, that answer is correct. Letter C, a reflection over one of the square's sides. Okay, let's pick one of the sides. Let's say we're going to reflect the square over its left side. If we reflect it over its left side, it's going to end up there. So again, you could see there that the square does not land on top of itself, so that answer is wrong. Letter D, a rotation of 180 degrees clockwise about the square's center. So there's the square's center. If we rotate it 90 degrees and then 90 degrees again, the square ends up looking the same. So that one is correct. And letter E, a reflection over one of the square's diagonals. All right, so if you draw a diagonal line from one corner to the other and reflect the square over that diagonal line, because it's a square, it will match up. So therefore, that answer is correct. If it would have been a rectangle, then it would not have worked. But with a square, it does work. Okay, let's go to question number 2. Identify a line that the rectangle could be reflected over to result in a rectangle that has the same vertices as the original. In other words, which one of these lines, when you reflect the rectangle over it, will put the rectangle on top of itself? Our first answer choice is y equals 2. Y equals 2 is a horizontal line right there. If we do a reflection over that line, you could see that the rectangles do not match up. So that answer is wrong. Letter B says x equals 2. Now obviously on the exam, this is imitating what's on the exam. You need to know the difference between how do you graph y equals 2 or x equals 2 or x equals 3. What does that line look like? Because if you don't know that, you're gonna have to guess. So make sure you look at how I'm writing those lines ahead of time, and if you have any questions, to ask me. But you need to know that for the exam. And on the exam, the lines are different. It's not y equals 2 or x equals 2, because I'm imitating what's on the exam. Okay, so for letter B, the line x equals 2, that's going to be a vertical line. Okay, now if I reflect the rectangle over that vertical line, again, you're going to see that it does not match up, so that answer is wrong. Letter C, the line x equals 3 is going to be a vertical line. And again, if you reflect over that line, the rectangles do not match up. So our last choice is the line y equals 3. Y equals 3 is a horizontal line. And as you can see, if you realize that, then this is the answer that'll work. If I do a reflection over that line, the rectangle does match up. So that is the correct answer. Question number 3. Which transformation of triangle ABC would yield triangle A prime, B prime, C prime so that segment BC is parallel to segment A prime, C prime? So what I'm going to do is take you through all these different transformations. Again, there's a question on the test just like this one. I've done it slightly different, but basically like this, all right? So letter A says a reflection across the x-axis. If I reflect that triangle across the x-axis, I'll have that triangle. Okay, so there I have my pre-image and my image. Now let's look at the sides that they're talking about. Side BC and side A prime C prime are perpendicular with this transformation, and they're asking us for parallel. So this answer is wrong. Let's look at letter B. Letter B says a reflection across the y-axis. So if I reflect the pre-image across the y-axis, I'm going to get this image. Again, let's look at the sides that they're talking about. Side BC and side A prime C prime are once again perpendicular. So this one is also wrong. Letter C says, let's skip letter C for a moment and let's look at letter D. Letter D says a 180 degree rotation about the origin. If you use your rotation rules to rotate this 180 degrees, you'll see that our image will land over here. So again, let's compare the sides. Side BC and side A prime C prime are once again perpendicular, so this one's wrong. So obviously our answer has to be letter C. Let's take a look at letter C. Letter C says a 90 degree counterclockwise rotation about the origin. All right, so if we rotate that pre-image 90 degrees counterclockwise, we're going to get this image. Now let's compare the sides, and you can see that side BC and side A prime C prime are parallel. So this is our correct answer. Question number 4. Draw and label the final image of triangle ABC after the given sequence of transformations. Reflect triangle ABC over the y-axis and then translate it by a vector of 3 and -5. Okay, so first let's do the first transformation, which is a reflection over the y-axis, and that's going to give us this image. And then we have to translate it by a vector of 3 comma -5. Remember that what that means, that vector, okay, the first number, the +3, means that you're going to move it 3 units to the right. So let's do that. Let's move it 3 units to the right. The second number, the -5, means you're going to move it 5 units down. So let's do that now. 5 units down. And there's where our final image is going to be. Now, keep in mind that the first number controls the movement left and right. If that first number is positive, that means you move it to the right 3 times. If it would have been negative, I would have moved it to the left 3 times. And the second number in the vector controls the movement up and down. Since it was negative, that means I move it 5 units down. If it would have been +5, that would have meant move it 5 units up. Okay, question number 5. Select all the transformations that will map rectangle ABCD to rectangle EFGH. So again, let's go one at a time and see which one of these work. Letter A is a translation of 6 units right. So if I move it 6 units right, you could see that the rectangle does not end up on top of rectangle EFGH. So that one is going to be wrong. Okay, letter B is a reflection over the line x equals -1. So first of all, let's look at what that is. The line x equals -1 is a vertical line that I have there in dark green. So if I reflect over that line, okay, we can see that our pre-image is 3 units to the left of that line. So if I reflect that rectangle over that line, it's got to be 3 units to the right on the other side. So that's how I do my reflection. Okay, now let's look at the second part. The second part is a translation of 2 units up. So let's move our rectangle 2 units up, and you can see that it matches up. So this is a correct answer. Okay, letter C, a translation of 2 units up. So let's do that. Let's move the rectangle 2 units up. And then we got to follow it with a 180-degree rotation about the point 1, 2. Okay, so let me show you what this means, because you can kind of visualize this without doing all the calculations, right? I'm trying to save you time on the exam. If I put a point at 1, 2, and I'm going to treat that as if that were the center, all right? So if we're going to rotate it 180 degrees around that point, this would be 90 degrees, and then this would be 180 degrees. It would end up on the right. It would not end up on top of our rectangle. Okay, now notice where I started and where I ended. All right, you should be able to visualize that without having to calculate the coordinates. Because if I explain how to calculate the coordinates, I'm sure some of you would understand it, but it gets a little tricky and a little complicated, and I don't want to make this problem harder than it is. The best thing is if you have a rough idea where it should land, that should be good enough to answer the question. So as you can see, letter C is a wrong answer. Let's move on to answer choice D, which says a translation of 12 units right and 2 units up. All right, so let's check. If we move it 12 units to the right, and keep in mind that this is jumping in units of 2. All right, every line is 2 units, so keep that in mind. So 12 units right and 2 units up, you could see that it does land perfectly on top of rectangle EFGH, so that answer is correct. Answer choice E. First, it says a reflection over the line x equals 0. The line x equals 0 is another way of referring to the y-axis. All right, the line x equals 0 is a vertical line at the y-axis. You need to know that for the test. This is on the test. So I'm telling you right now, if you're not, like, number one, I would study this before the test. And number two, if you're having trouble getting it, make sure to ask me, because I could give you little techniques to help you remember whether it's a vertical or horizontal line. But there's several questions where you need to know this on the test. Okay, so if I reflect our pre-image over that line, x equals 0, I'm going to get this rectangle on the other side. Okay, and now the next transformation is a reflection over the line y equals 2. The line y equals 2 is a horizontal line that I have in bright green. So if I reflect the rectangle over that line, it's going to end up on the other side, and obviously it does not match up with rectangle EFGH, so this is a wrong answer. The final answer choice, letter F, a rotation of 180 degrees are about point -1, 4. So on this one, again, I'm gonna what this means is we're gonna add this point, and we're gonna treat this point as if it were the center of the coordinate plane, as if it were the origin. We're treating it as if this was 0, 0. And without getting into the calculations, I want you to make sure that you know how to estimate where the rectangle should land. Okay, so if I were to rotate our pre-image 180 degrees around that point, this would be 90 degrees, and then 90 degrees again would put it right there. So that does match up. So that is a correct answer. So this question has 3 correct answers. All right, question number 6. Which sequence of transformations will map triangle ABC onto triangle XYZ? Again, let's go one at a time. Letter A, a rotation of 180 degrees clockwise about the origin, followed by a dilation. Okay, on this question, let me point out how we could do it quickly. If we're dilating our pre-image, that means in this case we're dilating it by a scale factor of 1.7. That means we're going to make it bigger, and it's not gonna be the same size as triangle XYZ. So just from that information alone, we don't have to do anything else. We could just mark it wrong because they're not going to match up. One triangle is going to be bigger than the other. Make sure you realize that, because there are a lot of questions. I mean, this is going to come up in a few other questions later in this review. And by realizing that, you're going to save yourself a ton of time, because you could immediately see that if you're dilating it, it's not going to be the same size, and you can mark it wrong. Okay, answer choice B. A reflection over the x-axis followed by a reflection over the y-axis. So if we reflect our pre-image over the x-axis, we're going to get this shape. And then if we reflect it over the y-axis, we're going to get this. All right, so that answer is obviously wrong. Letter C. In letter C, first we got to do a rotation of 90 degrees clockwise about the origin. So if we rotate our pre-image 90 degrees clockwise, we're going to get this. And then we got to follow that with a translation down 1 unit and to the left 10 units. Again, you should be able to visualize all these things, but obviously if you visualize this, you should be able to see that the triangle is going to end up outside of our box, outside of our coordinate plane. So that answer is wrong. And answer choice D, a rotation of 270 degrees clockwise about the origin. So let's do that first. If we rotate it 270 degrees clockwise, we're going to get this. That's 90, that's 180, and that's 270. And then we got to follow that with a translation left 1 unit and up 10 units. Left 1 unit and up 10 units. There you go. It's going to end up matching up. So that answer is correct. Okay, now for the next few questions, they're about rigid motion. And I actually added some more detail to this slide. I told you that rigid motions are translations, reflections, and rotations. But I gotta add an important detail that they try to trick you with on a lot of questions. The detail is this: a dilation by a scale factor of 1. That means that you're multiplying either the x or the y coordinates or both of them by the number 1. If you multiply by the number 1, everything stays the same. So you gotta watch out for that. If they're dilating by a scale factor of 1, the pre-image is gonna stay the same size, and therefore it is rigid motion. In order to be not rigid motion, it has to be a dilation by a scale factor other than 1. It could be a number smaller than 1 or bigger than 1. But as long as you're dilating by a scale factor that's not 1, your pre-image will not be the same size and it will not be rigid motion. All right, so let's look at the next couple questions are all about this, so keep that in mind. All right, so question number 7 says, which series of transformations would result in a figure that is congruent to triangle ABC? You could answer this question in literally a second or two. All right, so what I want to point out is this. Notice how all these answer choices, it talks about a dilation with a scale factor that's not 1. So those first 3 answer choices are going to make the, if you do those dilations, the pre-image is going to become bigger in all the cases. All right, so those 3 are wrong automatically. Because again, if you look at the question once again, it says, which series of transformations would result in a figure that is congruent? Congruent means it has to be the same size as the triangle ABC. And if you're dilating by any of those numbers, by a scale factor that's not 1, it's not going to be congruent to triangle ABC. So that's how I'm able to quickly eliminate those answer choices. The question that I'm imitating on the exam also has these answer choices, these similar answer choices, right? They're I didn't word them exactly the same. I changed up my question a little bit, but I'm imitating what's on the test. Okay, so if you look at answer choice D, okay, we don't have to work it out. By the way, on this one, we don't have to actually, it doesn't really matter where the shape is going to end up. The only thing that matters is whether or not the shape is going to end up the same size as when you started, all right? Because that's what the question is asking you. Which transformation is going to result in a figure that's congruent to triangle ABC? So it doesn't matter where it ends up on our coordinate plane. It just matters whether or not it's going to be congruent, whether or not it's going to be the same size. And in answer choice D, they're saying a dilation with a scale factor of -1. Let me talk about that a second, okay? The negative sign, all that does is that makes a reflection. So the negative sign, you could ignore it. The negative sign just means that it's going to be, that the pre-image is going to be reflected. What matters is the number 1. The number 1 means that it's going to stay the same size when you dilate it. So therefore, it's going to be congruent when you dilate it. So answer choice D is the correct answer. Again, I'm imitating a question just like this on the exam. Okay, but on the exam, it's all going to be scrambled up and all the questions are going to look similar. So if you don't really know it that well, you're easily going to get tricked on the exam or forget what was in the review. You need to study this. That's the only way you're going to remember it. Watching this video during my class is not going to help you remember it. You'll forget it by the time the test comes, trust me. All right, question number 8. Rectangle ABCD is shown below. Point E is the center of the rectangle. Which of the following transformations will preserve the length of the rectangle's sides? Select all that apply. Whenever you see select all that apply, that usually means that there are more than one correct answer. Okay, now let me talk about this question a little bit. It says, which of the following transformations will preserve the length of the rectangle's sides? That means keep the length of the sides the same. So if when you do these transformations, the length of the sides stay the same, then that's a correct answer. So in letter A, it says a translation of 5 units to the left. We know that a translation is a rigid motion. When you translate a shape, it stays the same size. So that means that answer choice A is correct because it's going to preserve the length of the rectangle's sides. Answer choice B, a reflection over the side AB. A reflection is also a rigid motion, so it's going to preserve the length of the rectangle's sides. Answer choice C, A dilation of scale factor 1. So as I said on the previous question, if you're doing a dilation by a scale factor of 1, the shape is going to stay the same size. So that's also going to be rigid motion. Letter D, a rotation of 90 degrees. A rotation is rigid motion, so that one's also correct. And letter E, a vertical stretch of scale factor 3. Okay, so since we're dilating it by a scale factor of 3, that's not rigid motion, okay? Whenever you dilate by a scale factor other than 1, it's not rigid motion. So listen, I want you to make sure you realize that this question has 5 answer choices and 4 of them are right. Because what a lot of students will do is they'll say, nah, 4 questions cannot be right. It's maybe 2 or 3, but 4 is too many. So realize that some of these questions have 4 correct answers. If you study ahead of time and you know what you're doing, and by the way, I forgot to put that the last one is wrong. But if you study ahead of time and you understand the concepts, then you won't be tricked by stuff like this that has a lot of correct answers. You need to study in order to remember this. All right, question number 9. A triangle is plotted on the coordinate plane. Each of its vertices undergoes the same transformation. Which rule below represents a transformation that does not preserve the length of the sides of the triangle? So again, this is another similar question to the last 2 or 3. You got to remember what rigid motion is. So this question we can answer very quickly. The first one, basically the first 3, I meant to do the animation a little bit different on this. But let's just jump to the wrong answer so you can see how you could identify it quickly. The way to do this question quickly is to just look through it and see which is the only one where either x or y is being multiplied by a number other than 1. So if you look at all the answer choices, in this case, letter D is the only one where x or y is being multiplied by a number that is not 1. So that's the only one that's being dilated by a scale factor other than 1. So that's how we could just look at the answer choices and quickly pick out which is the wrong answer. So if you know that, you could do this question very fast. If you don't know that, it's all going to look like randomness to you. And you're going to think that geometry is so complicated when really it's very simple. Okay, next question. Question number 10. Triangle ABC. Okay, before I read this one, this is one with a lot of words, and I know how you guys think. All right, and a lot of students look at this and they're just gonna guess at it because they're too lazy to read this. But if you read this is another very easy question, but you have to take the time to read it carefully and make sure you understand what it's saying. So it says triangle ABC is transformed to create triangle DEF and triangle XYZ as described below. DEF represents the translation 5 units right and 3 units up of triangle ABC. XYZ represents the dilation of triangle ABC by a scale factor of 6. Which of these is correct? Okay, now if you scan the answer choices real quick, they're you know what? Let's just do it this way. First of all, let's look at triangle XYZ first, all right? XYZ represents the dilation of triangle ABC by a scale factor of 6. Okay, so we already know that when you dilate a shape, the angle measures are preserved, but not the side lengths. That means that when a shape is dilated, the angle measures will stay the same, but the length of the sides will not. Okay, so let's keep that in mind as we go through some of these answer choices. For example, answer choice A says that the transformation of ABC to XYZ preserves the side lengths, but not the angle measures of the triangle. Again, picture what I'm telling you. When you dilate a shape, when you make it bigger or smaller, the angle measures are going to stay the same, but the length of the sides are not. So when you read this answer choice A, it's saying that in triangle XYZ, the side lengths are going to stay the same, but the angle measures are not. That doesn't make sense. The angle measures are supposed to stay the same, the side lengths are not. So A is wrong. If that sounds complicated to you, what you need to do is before the exam, look at the video and pause it and read the questions slowly. Or sometimes you need to read something more than once in order to get it. All right, let's look at answer choice B. The transformation of ABC to XYZ preserves both the side lengths and angle measures of the triangle. And no, that's not the case. If we're dilating it by a scale factor of 6, that means that the length of the sides is not going to stay the same. It's not going to be preserved. So that answer choice is wrong. Okay, so now let's look at our next options. Our next options are about DEF. So if we look at the question, DEF represents the translation 5 units right and 3 units up of triangle ABC. When we translate a shape, it's going to stay exactly the same in terms of its size. The size is going to stay the same and the angle measures are going to stay the same. So with that in mind, let's look at answer choice C. Answer choice C says that the transformation of ABC to DEF preserves the angle measures but not the side lengths of the triangle. That's wrong. Answer choice D is the only one that says correctly that the transformation of ABC to DEF preserves both the side lengths and the angle measures of the triangle. That is the correct answer. This is the type of question that you should definitely study ahead of time so that when you see it on the exam, you'll quickly recognize it because this is very closely imitating what's on the exam. If you study it ahead of time, you'll quickly recognize it and you'll be able to process it quickly and answer it quickly. Now, if you don't study it, when you see this on the exam, you're going to be reading it slowly for like 10 minutes trying to make sense of this when it's actually not that difficult at all. Okay, question number 11. List all the angles of rotation less than 360 degrees for a regular hexagon. When you see the word regular in geometry, that means that all the sides are the same length and all the angles are the same measure. All right, so again, when you see the word regular in geometry, that means that the length of each side is the same and the measure of each angle is the same. So in order to solve this, what we're going to do, this is like the Ferris wheel problem that we had on our homework assignment, and we did a whole mess of problems like this. Okay, you have to remember that a circle is 360 degrees. So we're going to do 360 divided by the number of sides in this shape. This shape has 6 sides. So 360 divided by 6 equals 60 degrees. And now just list all the angles, all the multiples of 60 that are less than 360. So 60 times 1, 60 times 2, 60 times 3, 60 times 4, and 60 times 5. Question number 12. Triangle ABC is reflected across line G to form triangle DEF. Okay, on this one I didn't really have time to put a bunch of different answer choices. So I just put make sure you understand which corresponding sides are congruent. So what you have on the screen is the correct corresponding sides. But on the exam, you're gonna have it all mixed up with different letters as they try to trick you to see if you understand which side goes with which side. Remember that the order of the letters is very important. The order of the letters has to be exactly correct when you're comparing the sides. Question number 13. You're gonna have a couple questions like this that have several parts to it, several questions inside of that one question. So in question number 13, it says a student claims that triangle ABC is congruent to triangle XBZ. Determine which statements must be true for the student's claims to be valid. So let's look at our first possibility here. The first answer choice says triangle ABC can be rotated about point B to map it to triangle XBZ. All right, so if you visualize rotating triangle ABC around point B, there's really no way that it's going to land on top of, that you can map it on top of triangle XBZ. So for that answer, I'm putting maybe false. For the next one, it says a series of rigid transformations map triangle ABC to triangle XBZ. Well, you should realize that you could do a reflection to put the triangle ABC on top of triangle XBZ. So therefore, that one must be true because you could reflect it. And a reflection is a rigid transformation. For our third answer choice, it says the measure of angle A is congruent to the measure of angle X. And yes, those two angles are corresponding angles, so that must be true. And for our last answer choice, CB is congruent to BZ. CB is congruent to BZ. That means that the distance of CB has to be the same as or let me say that better. The length of segment CB has to be the same as the length of segment BZ. So on this case, that has to be true. For this one, it doesn't matter that the order of the letters is not like it's not CB to ZB. I mean, if they would have written that, that would have been correct as well. But because they're just talking about the length of the segment, that one must be true. All right, for question number 14. Okay, this one you definitely need to study ahead of time because this one is very difficult to understand if you've never seen it before. And they're not going to give you a diagram. They're not going to give you a picture. I'm going to give you a picture in a second, but they do not give you a picture on the test. So if you don't look at this ahead of time, you're going to be completely lost on this question. All right? And I'm not going to help you during the test because I'm helping you now. You need to do your part and study. All right? So first, let's read through it. Okay? It says, let E be a point not on line H. Let E prime be the image of E after a reflection about line H, and let V be any point on line H. Determine whether each statement below is true for all points E, true for some points E, or not true for any points E. And as I said, be prepared to answer a similar question without a diagram. Okay, so let me show you a diagram that I made of this situation that you should learn it so that you could be able to draw it, sketch it out on the exam, and answer these questions, right? Here, I'll read the question again as you look at the picture so it'll make more sense. It says, let E be a point not on line H. Let E prime be the image of E after a reflection about line H, and let V be any point on line H. All right, so the location of E, I just put a random location and then reflected it to the other side. And the location of point V, it says let V be any point on line H. You could put it anywhere. I decided to put it there. But you could have put it anywhere on line H. All right, so now let's look at the different answer choices to see which ones are correct and which ones are wrong. So our first answer choice says line H bisects E prime. That means that line H is going through the middle of the distance from E to E prime. And that is true for all, right? Because line H is going through the middle of, if we were to draw a line from E to E prime, line H is going through the middle of it. All right, for our next answer choice, EV, the distance from E to V, is going to equal the distance from E prime to V. That is also true for all. Our third answer choice, line H is perpendicular to E prime. Line H is perpendicular to E prime. That is also true. If I draw a straight line from point E to point E prime, line H will be perpendicular to it. And our last one, line H is parallel to E prime. That one is not true for any. Right? Line H is not parallel. Notice that there's no answer choices. None of the check marks are for the middle section. So again, I'm imitating what's on the test. If you don't study ahead of time, when you're doing this on the test, you're gonna think, oh, there must be at least one of them that's true for some, and that's gonna mess up the entire question. All right, so study ahead of time. All right, question number 15. If triangle STR is congruent to triangle EVH, then which of the following are true? Um, okay, so on this one, I'm gonna point out which answer choice they try to trick you on. And unfortunately, I did this very late. I did this like I needed more time to add more stuff to this review, so I didn't have time to highlight what I want to highlight on this one. So you're gonna have to listen carefully. So here, if you could picture this, answer choice one, it says that segment ST is congruent to segment EV. That one's easy. That's correct. Answer choice two, TSR and VEH. Okay, that one's easy as well. It says that angle TSR is congruent to angle VEH. If you look at the order of the letters, that one's easy to understand as well. That one's correct. Okay, answer choice 3 is the tricky one that you need to pay attention to. And by the way, the correct answer is 1, 2, and 3 are all correct. But answer choice 3 is the one that I want you to look at because that's the one that they try to trick you with. Okay, keep in mind that when you name an angle, all right, if you remember when we went over naming an angle, I said that the letter of the vertex has to be in the middle always. The letter of the vertex has to be in the middle always. But you could name an angle in either direction. Like I could name an angle RTS, or I could name it angle STR. I'm looking at answer choice 3. So look at answer choice 3 as I say this. I'll say that again. I could name an angle RTS, or I could also name it angle STR, and it's the same angle. They're both correct. And if I look at, again, answer choice 3, look at the angle on the right. I could name that angle EVH or angle HVE, and they're both correct. They're both the same angle. Okay, so that's the answer choice that they try to trick you with, and that answer choice is correct. If you don't get what I'm saying, ask me about this one in class or before the exam, and I'll draw it for you so you can see what I mean. All right, but just be aware that they're imitating this on the exam, so you need to look at that ahead of time and make sure you study it. Okay, believe it or not, it took me a long time to put this review together. All that fancy animation, all right. It took me a lot of hours, and I actually didn't have time to put in. There's like three or four questions that I didn't have time to put on the review. So what I plan to do is to upload those to Schoology. All right, this video will be on YouTube, but I also plan to upload those questions that I did not get a chance to put on Schoology. So make sure you look at that because there are 3 or 4 questions that might be a little bit tough, and it's definitely worth studying. All right. But that's it for this review, guys. Make sure to study for the test so that you can get a good grade because I'm going to count it as 50% of your grade. 50% of your grade. So it's going to have a big impact on your grade. All right, guys, good luck.